We introduced this section of logarithms and exponential functions with a review of composite functions. A composite function is something that looks like this. Notice this is not a multiplication symbol. It indicates the composite function. This means f of g of x. When we say f of g of x, remember that you do your parentheses first. So this here is the first thing that you replace before you replace this. This is the second. So let's say we'll use number 15 as an example. Number 15 says f of x equals square root of x. G of x equals x plus 3. So we will say, what is f of g of 1? Remember, that means f of g of 1. The first thing we do is the innermost parentheses. This tells us to put 1 in to every x in g. What's g again? Well, g is x plus 3. So this really means f of, since g of x is x plus 3, you're putting 1 into g. So that's 1 in for this x. So 1 goes in there. So that's just 1 plus 3, or f of 4. This now, we do part 2. You're plugging 4 in for f of x. Remember that f of x equals square root of x. So that means f of 4, or 4 goes in for every x. So this is the square root of 4. So your answer is 2 for this. If we go the other way, g of f of 1. So that's g of f of 1. 1 goes into f. So g is now the square root of, because this was the square root of x, you're putting 1 in. So that's a square root of 1. Square root of 1 is just 1. Now you're putting 1 in for every g. Right? So put 1 into g. That means g is x plus 3. So that is 1 plus 3, or 4. Same problem, but let's just say now f of g of x, which means this. There's no number here. So all I want is, I see g of x here, I see g of x right here, I'm just going to replace it. G of x is x plus 3. G of x is x plus 3. And now I have f of x plus 3. Just like before, I'm putting x plus 3 in for every time I see an x in f of x. So if I have the square root of x and I replace this for every x, that means the square root of x plus 3. And that is my answer. With g of f of x, now I put the f of x in first. F of x equals the square root of 3. F of x is the square root of 3. So I just replace this with the square root of 3. G of x is x plus 3. I put this number in. Sorry, that should be an x. I put this in for every time I see an x. So g of x, or g of square root of x, is now the square root of x. I replace this with the square root of x plus 3. And that is my final answer for that. Let's move down to number 35. First, it asks whether a function is one-to-one. One-to-one means that there's only one value of x for every y value. So you could not have anything like a parabola because it does not pass not only a vertical line test, but a horizontal line. So what I'm saying is, if line test, a horizontal line test, means it would not pass through my graph more than once, because for every y value, like if this was 2, here I have 2 x values. That does not pass a horizontal line test. This one does, because it is one-to-one. The graph of this is just a line that says x plus 4, so if x is 0, y is 4. It would be a line like this. For every x, there's only one y value. For every y value, there's only one x value. That's what one-to-one means. So number 35, yes, it's one-to-one. So when you find a formula for the inverse, remember you replace the f of x with a y, these trade places, so x now equals y plus 4, then you subtract the 4 from both sides, and that is your inverse function. So the inverse function of x plus 4 is x minus 4. Let's go to number 55. We're going to say yes, that is a one-to-one function. So g of x is equal to x minus 2 cubed. We're going to replace that with y. Switch these two. And now we're going to solve. So to solve this, I would take the cube root of both sides. So this is now the cube root of x equals y minus 2. Solve for y, so that's the cube root of x plus 2 equals y. And that is the inverse of my function. Let's try number 60 as an example. Number 60 says g of x equals 1/4 of x plus 2. And we're going to practice graphing inverse functions. So to graph this function, we just plug stuff in for x and y. So if x is 0, y is 2. If x is, I'm just going to pick big numbers, or whole numbers, that's going to make this whole, so I don't have to graph fractions. X is 4. 4 times 1/4 is 1. 1 plus 2 is 3. If I plug in an 8, 8 times 1/4 is 2. 2 plus 2 is 4. If I plug in a negative 4, negative 4 times 1/4 is negative 1. Plus 2 is 1. If I plug in a negative 8, negative 2 plus 2 is 0. So I have 0, 2, 4, 3, 8, 4, negative 4, 1, 8, 0. Now, to find an inverse, remember, I can say g of negative 1 of x, that is an inverse. That is when we switch the x and the y coordinates. So now we're going to say x equals 1/4 y plus 2. Solve for y by subtracting 2 from both sides. Multiplying both sides by 4 gives me 4x minus 8 equals y, because those will cancel out. So g of negative 1 of x is equal to 4x minus 8. From that, correct? I'm going to graph. If x is 0, y is negative 8. If x is 1, that's 4 minus 8, or negative 4. If x is 2, y is 0. If x is 3, then that's 12 minus 8 would be 4. And if x is 4, we have 16 minus 8, which is 8. So we have 0, negative 8, 1, negative 4, 2, 0, 3, 4, 4, 8. And remember, your line should be reflected across this, because that's what an inverse means. The other way you can graph, notice, 0, 2 becomes 2, 0. Negative 4, 1 becomes 1, negative 4. Negative 8, 0 becomes 0, negative 8, because you're just switching the x and the y coordinates. So I hope that helps you go over your homework for 9.1.